Welcome back, guys. So today, let's continue with the actual implementation of the X4 structures and types in general. And yesterday, we were trying to actually implement the fields for an X group, and these are the offsets that we need to read the proper values out of the image that we want to read from. And we also started off with a small implementation of how our mount system will work. So in case user flow would be like whenever we add a new file system or a new image that we want to keep as a file system, we can mount it. And currently we only support X4 file system, so we'll mount it. And in general, and as soon as we mount it, we have to know what sort of things are in there. So we just read the metadata, and the metadata will be the super block, which is the zeroth block. That's what we are reading, and we check if it's a X4 file system, and then we can read further fields. And these are the fields that we can currently read. We can read the total inode count, current state, number of blocks, number of inodes, inode size, etc. So let's continue with this and try to finish the initial mounting process overall today, instead of wasting too much time, because it's been a while since we haven't yet finished anything. We are still, every time we just keep on getting into different theories and nothing is getting implemented. So today I want to finish this setup somehow. And other than that, overall, we're still working on the file system layer. We have the MMU scheduling and user process, interrupts, syscalls, all these stuff working fine in our kernel. And currently we are working on the file system layer, and the end goal is to be able to load ELFs from a file system and directly run those as user processes, because currently we have to hard code the user processes into kernel ELF. We don't want to do that, so we add the file system layer and load the ELFs from there, and that should be a good way, and it's gonna help us improve our kernel in future. So let's get into it. And yesterday we just kept figuring out the different offsets. We have defined them. Actual kernel, like a production kernel, the actual implementation should be to define every field of the X4 group and just cast it as with the base address. That would be the best case solution, but right now we don't really need all those stuff. So and in my kernel, it's I need to understand things and keep it simple, so that it would be easier to, in case someone wants to learn, and myself too, because if I'm implementing everything, it'll be too clustered and too hard to read, come back and read things. So if I only have the things that I actually need, then it would be easier to reason about later on. And currently, as of now, in the setup process, we have block read, which is to read the zeroth block, and then we also have the magic check to confirm it is actually a what is it X4 image. So if it's an X4 image, it would have this signature in the top, that is the zeroth byte. Now let's actually start implementing the next step. Yesterday we went through all the things that we want to do first of all, and once we actually try to initialize the thing and we read the zeroth block, after we read the zeroth block, okay, so here we cast it as cast that base address as the X super block, and then we actually read the field from it. So that means we can't simply say this. We'll have to say 1024 plus 0, and which is super block, I guess. Let's move all these here, and okay, we moved, and then we can just use super, what was that fucking name? It's empty bytes. Fuck. It's empty bytes plus 0, which should be this field, and empty bytes plus 1, which should be the second byte, and we want to read these 2 bytes and confirm if these values are this. And we also want to read the block size, so let's read the block size and put it as even 32, 16 is fine. Block size, and block size would be, we read the buff with empty bytes plus the size is super block. What was the naming? It's the X4. Okay, we need the empty bytes plus super x4 log block size. So if we read this byte would be the actual value, and maybe we can also cast it into U64. And 16. Other than that, we can also check what's the size. Just print it first of all. So can't block size is, let's put D. It's uint, but yeah, fine, I don't have a format specifier for that, so that's okay. What? Why? What is happening? Maybe I was pressing something else. Okay. One more thing, let's try to run it, because it will be hard to debug everything at a time. So let's compile it incrementally, so that what the fuck is this FT counter? I don't think we need this max FTs. Let it be. Let's comment this out. What the fuck is this? Is this? Think later. Okay. We don't need anything else. Let's add this into our build. We have a new C files. No, we only have a header file. Yes, we only have a header file. So let's just import this inside kmain. And where do we want to do it? We will do it here. Can we include that file here? No, it will be not good. Include which directory is it? Maybe it's just file.h. It is possible. It is inside core. Okay, that's fine. Let's copy this file and let's come back. Let's come back here. Okay, let's load it here. And we want it's not going to return anything, it's not going to take anything. We're just going to call mount4, and we can, let's call while. So we will stop here, we don't want to keep going. Okay, let's see. Let's also just add a print so that we know that we are here. Starting to mount x4 image, and also copy it, paste it, and done mounting. Done mount. Okay, good. Let's run it then. Let's get a new one. I think it's just the header file, so we don't need to include anything new. Now we just have to fix all the errors within the file. And what are those errors? It's unknown type file. Why do I get unknown type file? Maybe because file is implemented below. Okay, let's move everything to the bottom. Okay, what? Oh shit. Sometimes I forget all the commands. It's just so fucking annoying. Let's put it here. Let's see if we have all the things in. Now we have x4 that is below. Fucking hell. We need x4 group. The x4 group is here. Are we using it anywhere? Line number 157. Okay, so we are using it here. Okay. Okay, then let's move. Let's move this whole thing here. Okay, now let's see. Now we just have one error, which is unknown type inode. I guess I'm fucking with circular dependencies. I think this is file and file operations and inode and group operations. All those things should be above it. Okay. What about inodes? Inode has inode metadata and file types. Okay. And file operations. Okay. Let's just bring this. I'm going to end up with circular dependencies, I guess. What happened? It's okay. I can manage. Let's move this above this. No, about this, because I still need file. File should be in the top and file operation should be above that. Where the fuck is that? File operations. Okay, there's nothing here. Fuck me. Inode metadata is in the top. File types is also in the top. So these two don't depend on anything else. And I can also keep this because this does not depend on anything else. This depends on group operations and super block. So super block is here and group operations is here, and group operations is needs ext4. See, yeah, group operations needs ext4 and ext4 needs ext4 needs group operations. Oh, fuck me. I think we'll just put void there and we'll cast it internally. I think there's one solution, or I just have to reorder things, but I have ext group and group operations, and group operations internally needs ext group. How do people actually solve this? What happens if a structure wants a structure internally and that structure needs actually this thing is why I have given it as this is like self parameter in Python. So because this structure is part of ext4, I was assuming we can take it as self. Okay, it's fine. It's not bad. We can still just put voids and we can internally but let's just ask one question to see if how in general people handle this case, because maybe it will be useful for us in future. how do we solve cases where a struct needs another struct internally? No, I don't wanna clobber this session. Let's just have it as it is. Where the fuck is it? No. What? Did I just move past it? Maybe I did. Okay, yeah, this is it, I guess. Feels like I'm just going back to the top again. Okay, that is what is happening. Again going back to the top. Okay, this is where we left off. This is the table. Okay, leave it as it is. Now what we need is how to have circular structs dependency to get self feature in C, because this is the exact scenario. So this is the main class and it has an internal class, and that class, let's assume that it wants self parameter. Self parameter means that it needs object to the parent class. So that is what is this. So it is the first parameter is just self, which is object of the parent class. So but currently it's not possible. I mean, at least it feels not possible, because this needs this to be defined, but to define this I need this. So it's like circular. So yeah, let's see. Symmetric forward declaration. Okay. But if I declare this, then again I won't be able to declare the second B, right? So initially I just declare B as something, and inside the structure A I use that pointer, and inside structure B actually it works, because here we are, I don't know how it will actually work, because as soon as I include this, that means I'm actually including this type definition there. Then how can I have this type definition and this type definition? But the difference is, I guess here we have used type def and it's just struct. You just forward declare it and use it. I think that's the solution. I just simply have to um, forward declare it. But what does that mean if I forward declare like struct? Shouldn't that be an error? X4 group. Let's run it. Okay, it's in the fifth index. What the fuck is this then? Let's close this. Let's close this. What's this? In 1 I have this, and in 2 I have this, and in 5 I have this. Okay, let's close this too, and let's go to 1, and here let's put bash. Okay, I'll put type def. How do we define a empty type def? Okay, you just put a space the actual type x4 group. This is just like defining the function signature in the top and having maybe linker doing the actual work. I hope so. Okay, now we don't have inode. Why we don't have inode? Where the fuck is inode? These three actually can be in the top, I believe. Let's put them in the top. File type, it's just basic. File type is there, inode metadata is also there. Okay, hopefully this won't. No, we don't have file operations. The fuck is file operations? Okay, file operations is here, and I think this can also go below this because it only needs file. And okay, even for this I have to do forward declaration. Okay, it's type struct underscore file. Type struct underscore file. Okay, let's see. Okay, now it's working. Something went wrong. Okay, what went wrong? Okay, at least the circular dependencies is done. So in case we want to have these features, we simply have to declare it in the top and then define it, similar to having a function signature and declaring it in the bottom. That way we can have circular dependencies. Okay, that's fine. And let's just dump the entire thing. We want printf yell full dump. And have buff. Okay, now let's run it. I think it's just my block read operation is slow, probably. Or either this, it does not like this file 4096. Probably we need to call, just pass, read it multiple times. Maybe that's the case. Let's try to read. Okay. How many bytes did you actually read? I think that's the issue. We just have to call it in a for loop properly. And let's call that let's see. What the fuck? Red is just 1 and this is what we got. What the fuck is this? What the fuck is that? That looks like an address. Am I just printing the address? Ah, okay. My fucking brain sometimes does not work. Let's put yes here. Now we should be able to print it. Why is it not working? We have block reads. We're passing the size. Now I have only passed 512. What's wrong with 512? What the fuck is wrong? I mean, block read, block write, both has worked. Size of 512. What the fuck is this? Oh, size of 512. It's 512. Sometimes we write stupid code and something somehow works. I think if we print it this way, maybe it will work. Let's try. As our attach. Let's print it here. And it is going to be buff. Okay. And then we don't need this. Let's just put full dump is over here. And let's just dot put here. Start and end. Okay. Now let's see what's inside there. Sometimes this is stuck. Probably it's inside that while loop, trying to see if the status bit is correct inside which I have. Probably that is what is happening. Yeah. Okay, we starting to read the first bits and it is the same. Okay, what if we read 4096? Will it work? 96 and 4096. Let's see what happens. Holy fucking holy. Okay, we did read something. And so it does work and it has something. And let's try to read from. Wait, what happened after that? What the fuck? There's so many race conditions in my kernel. Everything is trying to work with just a single thread. Start. let's remove the logs entirely, so it'll be fast. Just by removing this one line, my kernel will be super fucking fast. See, I just pressed enter and it came. And it has a lot of data. Okay, so let's my kernel is so fucking fast. It's the Camus that is slow. Okay, when I I need to read from 1024. Let's see. And my first few bits are like this. Let's convert them into hex. And the hex looks like this. And what the fucking hex are we trying to read? It does not match. It is completely different. I don't know what the fuck is this. But for sure, the text data starts at 1000 because something is in here at around 1000 bytes, 1024 bytes. Maybe the LLM just fucked with us. Maybe it's not supposed to have the bytes here. Also, maybe it's possible that we need to read it from first block. It's definitely possible because some latest text force have it in the block number 1, not block number 0. So let's try. Block number 01024. Let's see. And here we just have zeros. So definitely not that case. So wait, let's check my X4 image once. Maybe we fucked up our X4 image. But if we had fucked up on the Camus, what is that? Which IO layer should have failed? If which IO layer is able to read it, then we should also be able to read it. And this is the X4 image. I guess let's just create one X4 image. A new one. And how the fuck do we create it? I don't remember. Let's go back one step and grep for DD. I don't like this. Can we remove all? How do we remove that? We find and grep for Camus -1. Okay, there's only one file, then I can remove it. Kernel simple MMU Camus 1 log. Now if we grab for DD space. Oh fuck me, bro. What the fuck? There's no fucking DD command at all. Let's try .img. must be some sh file I used. Let's see, run. What the fuck is inside run? Okay, not that. There's builds rootfs.sh. Okay. I think I could just simply download a X4 image. X4 Debian rootfs. Download. Nobody has already built the image. You fucking piece of shit. Oh shit. There is packages. I just need the image. How hard is it? What is this? Maybe this is the image. What the fuck is that? Okay. Let's just put it inside desktop. Let's copy it here and give a test. Temp temp move desktop Debian. Okay, tar xvf. Oh fuck. It's Debian. What the fuck? It is just putting every damn thing here. Oh shit! It's the entire file system zipped. Maybe I can just convert this into an image. I don't remember any of the commands though. I think we'll have to install Docker and run this internally and get it out of it. There's no other way. Okay. mkdir tu cdtu and cp build here, and then let's start Docker, because it's hard to build those images in Mac directly. I don't know. Hi, how are you? Good. I'm doing good. Running image. Let's build a small Docker pull Ubuntu Debian 12. Okay. Docker exec it Debian bash. What? Docker images. It's Debian. Why the fuck it is not working? Okay, it's not a container. Okay, it's from Debian 12. Okay, it is working. So let's just put let's mount this directory into tu, and if we go to tu, we have the boot. Let's just put every update, and now let's run build root. What the fuck? Oh shit. Build root. Okay. Now we what the not permitted? What the fuck do you mean? What the fuck is that, first of all? What was the error? Maybe we need to install something. Cannot install target into I have no fucking clue. I have no fucking clue. Let's just search this. Oh shit. I didn't understand. I think it's some sort of permissions that are missing. I think let's just put here temp cp du bash builds. I knew it. I knew the fuck. Yeah, it's just because the fucking Mac OS is read only for some reason, so we can't simply mount anything from the host into a Docker and do things. It simply does not work. But we can do anything within the directory that is already part of the container. Okay, final mount failed. That's fine. At least I have the root image, rootfs image. Let's check that. Okay, I'll cp rootfs into tu and exit, and I have the rootfs here. Okay, now I have a X image. Okay, now if I copy tu rootfs here, and I need to put it inside xcp rootfs that image into x4. Where the fuck is x4? Kernel x4. Okay. Now we should have it. Let's put bash builds. Even now we have almost similar. Where is it? And what are we reading? We are reading from first index. Let's read from 0th index. And let's see. And 0th index does not seem to 0. Let's put here. And if we read, this is what we get, and it is not the same. How to read x4 image magic head bytes. XXT. Do we have XST? Oh, we do have XST. Magic number. 1004 bytes plus 38. Let's see. So it's not the 0th byte. So we fucked up already. So it is 1024 plus 38. 38. There's 80. And x4 mg. Why the fuck is it printing everything? Maybe we have to just give L2, and it is that. So the question here is empty bytes plus 0 is not this. Who the fuck told us that? That's the issue. That's why we fucking should not believe this LLMs. Or maybe I read it wrong. Okay, it does say it is in 38th byte, so it was my fault. Okay, so I assumed that it will be in the 0th bytes. It's my fault. Sorry guys, the whole debugging is because of me. I fucked up. I thought it will be in the first bytes. I don't know why I assumed that. Okay, let's just define that bytes then. ext4 magic bytes, and it is 0x38. So that means empty bytes plus ext4 magic bytes ext4 magic bytes plus 1. Okay, let's see. Oh shit, not this. I cannot come back every time again. Let's open this here and let's move to first window. And let's build it. And if we dumped it, and then we are trying to we need to read empty bytes plus magic bytes should be equal to EF. Let's just print those bytes then. We need two things. First one is our the first one, and then we have the second one, which is this. Okay, let's fix it. Now let's see what happens. We have 83 and 239. What the fuck? Maybe it's because of decimal representation. So if I read it directly, it will be a character. Okay, maybe that's the issue. Let's see what's the character of 83. 83's hex is 53 and 239 hex is EF. So it is correct. It's just that everything is in Little Indian, so I have to read it from left to right. No, right to left. So I have to swap the bytes. Oh shit. So we have this issue. So if we start from the 38th, everything is placed in the memory in Little Indian. So every time we read a 32-bit value, we have to swap it. That's even worse. Okay, it's fine. Plus 1 and this, and it should be 230, 239, and this should be 83. Okay, at least now we know that our entire layout is swapped. We have to think about that too. And current block size is 2. Block size works. Okay, if I'm taking the entire thing as U32, then I think it should work without having to, because in general ARM architecture does it like that. Probably that's why. So it is working. It is working as 2. Let's test that theory. If we want, what do we want? We want this, and if it is laid out like this, oh shit. If we convert it, it will be this decimal. That means, first of all, how many bytes I need to read. If I just know that I can cast that is 2 bytes. So it's uint 16. I think so. So let's try one more thing. Let's put D, and let's try uint 16 from this. Uint 16. Let's see if we get. What are we supposed to get? What are we expecting here? I don't know. Let me see. We're only getting 83. Let's see. Let's put 32 then. Still, how can we cast the entire thing into one? Actually, what do we need? We need the first bit is 53, second bit is EF. That means it's already correct. So why the fuck did I change it? Because the first bit is 53, which is decimal of 83, and second bit is what is it? EF, which is 239. Sometimes I just do shit without even understanding what the fuck am I doing. 239 plus 1. I think now it's correct. Only thing we had to change was the hex into decimal, nothing much. We didn't have to change anything else. Okay, let's check this one as not equal to 1, and then we can dump it if we want it, and then we have the bytes check, and then we have the block size. Okay, what else do we need? Na 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 na. What am I looking for? I'm looking for the table that I initially had. Must be here. I think it's in the top. I think this is the table. Okay. That's also we can do this part, but we are not going to do that. That whole thing is gone. Let's just recheck. Uh, check my current implementation. I have mounts x4. It's few stuff. Plain. What else we have to do in our full flow? I think it lost in the scroll for some reason. Ta-ta-ta. Once we have the block size and I actually had a list of things to do before that table. For some reason, I was not able to scroll back that. I don't know how. Maybe it got cleared for some reason. I'm not sure. So I was just following the steps. First of all, we need to read the magic number and we need to read the block size. And what else we do? Okay, so we have allocated a 4K buffer. We read the 0th bit. We checked the magic bytes. And then what do we do? Maybe my this return value is wrong because I am able to read the entire thing, but it always returns 1. Okay, that's for some other day. I don't care about portability. Fine. And block size. Yeah, I was wondering the same thing because probably we are just reading 1 byte of it, and because it's 2, we are able to read that. Okay, we just have to cast it as a pointer. Oh, fuck. So we take this address. We don't index it. we simply put this buff plus empty bytes plus log size. So this will be address. So this is buff is the base address plus empty bytes plus log size. Now we have a pointer and we cast it as u32 pointer, and finally we dereference it. See what happens first of all. Let's see if it works. Okay, it works for this case. Maybe that is what I want to do here too, because I was trying to do something and then I gave up. Let's see. I consider this as a event pointer and I don't index it. I'll just give it as the base address. So I have a base address and now I that. Now what happens? Now I get 257875. What is this value? What the fuck is decimal? Ah, okay, let's try 53EF. It did not match, so I'm reading something wrong. Empty bytes, magic bytes. What if I read magic bytes plus 1? Then it is showing 6772223. That also does not make any sense. Let's read it as 16 then. Six one two six seven. Does it make sense? 53. Okay, now it makes sense. 61267. So it is just two bytes. It's not u. It is u in 16. Magic bytes is so 2 bytes. So we only read the first 2 bytes, which is, and then we are able to just get it and we check it separately. And then here we are directly casting block size as u 32 and we are getting the block size. Okay, and that is also working. Now let's go back. What do we want? We have to multiply 1024 into block size. Not the size itself. Okay. It is log block size. That means the block size value would be un 32 block size and it would be 1024 log block size. What is this? What will we are doing left shift? No, we are doing right shift. No, we are doing left shift. Left shift means we are multiplying by 2. Right shift means divide. I fucking forgot. Let's just test it. And 0, 4. Okay. Into 2 and then another into 2. Okay. So it is 2 power 0 and 2 power 1. So that is what happens here. When we shift it twice, we put 2 power 0 and 2 power 1. Probably that is the case. We shift it twice. So we multiply two times. Okay. Okay, we have the block size. Now what do we do? Okay, so root inode value is always 2. Why? Root inode, let's search it. Root inode number for x4. Okay, so it is root inode 2. 2 will be always be the root inode. Okay, I guess we can take that as a fact. Okay, so this is number of groups, because the entire physical blocks is converted into groups, so we need to know how many groups are there. Only then, whenever we have a bytes, we can divide it by that groups and get the group number, and then we get into it and get the block number and do all sort of calculations. Block count and blocks per group. Okay, so we'll put, we have blocks per group already here. Let's take block count yellow, and what's the number for it? Okay, we have low and high. We just have to convert into 64 bits. So I'll put hi, and it is high is in 150 and low is in 04. Why the fuck it is in completely different locations? Okay, let's group that together. Let's first of all read both values, and both are size of 4, so we can I think we can write a small static helper to cast every data. So we put static inline cast as uint 32, and we can take a uint 64 value add, and it's going to return the pointer or the address. It's going to return the value int 32, and it's going to be uint 32 star addr. Okay, now we don't have to write that same thing 100 times. We can just call cast as uint 32, and we can again do the same thing here. We need a uint 32 and count block count lower half as cast as uint 32. Let's just copy this whole thing. And we can put block count yellow, and we copy this again and we put block count higher, and we should high. Okay, now we have both the things. We can now, how the fuck can we group it into one higher value? I think we need to shift it 32 times, and then I think so, yeah. Static inline uint 64 d group as uint 64. So it's going to take upper and lower uint 32 upper and uint 32 lower, and we need to return first of all we need to create we just need to move the upper half into the top bits, so it should be uint 64 temp equals 0x 1 2 3 how do we actually move a byte to the upper bits? We just have to shift the 32 bits from here to there. That means I can yes, I can do that. What I have to do is just take a uint 64 value. Maybe I'm going to do something stupid, but I think it will work. And I just AND it, R it with upper. Yeah, because currently the upper is still in the lower half. And then I can shift it by 32. Now we should have the things in the end, and both are things, so we can now return temp R lower. Will it work? I think it will work. I don't know. And let's just confirm it. I think this is technically the same thing, because what does is this is just directly casting the upper value to U64 and then shifting it and then Ring it. What I am doing is I'm taking a random uint64 value and then I'm Ring it with the upper, so I'll have the upper half zeroed and the lower half just the upper value. I think that is optimized version, and my version is stupid version, but still my version should work. And then I'm just shifting it 32 bits and I'm Ring it, so it should work. We'll keep our stupid version, and then you can take block count uint64 block count equal to group as uint64 and it was upper, so block count higher and block count lower. Now we can print it uart current block count is should be block count. Okay, now let's run it. What the crap? Character star into, what the fuck do you mean? Okay, this is an address and we add it all. Okay, no, let's just put even 64. What we take this as address, and then we add rest. I think it should work. Okay, now we have block size as 4096 and total block count as 524288. Hopefully this is correct. Okay, what else? Now we can move to the next thing. Okay, so number of group is block count divided by blocks per group. How do we get blocks per group first of all? Okay, we have blocks per group here. Okay, we can read that then. Per group, and we cast it as x4 blocks per group block count, and then we put UN 32 number of groups equal to, it should be block count divided by number of groups. Okay, number of groups, and it's B, number of groups, blocks per group, it's blocks per group. Oh shit. Okay, we have current group and blocks per group, and we get the number of groups after that. What? No. Sometimes I press U instead of yank, and it does whatever it has to do, which is so sad. Current number of groups is what? Blocks per group is 3276, and the current number of groups is block count divided by number of groups. Maybe there was some thing that we missed. Oh shit. Blocks. Okay. Now it will work. We just have to write proper code instead of writing stupid code. Okay. Number of groups is 16. We have 16 groups. Okay. What else do we need? And yes, we need to store this. Yeah, I mean, like once I have all these values, I have to create a ext4 group and store these values. And within that, I'll have the super block, which are these values. Okay. I have block size. I have count. I have blocks per group. Now I need inodes per group, inode size, and also probably description size. Okay. I need inodes per group. So it would be inodes per group. And I also need inode size. Inode size. Okay, now I have inode size. I have inode group. Okay, I'll just move this to here, and then I can copy this and paste it here. I can say inode group count is and inode size. Okay, inodes per group and inode size. Okay, that is it. I have the inode group, inode size. I'm not going to do the feature thing, and maybe you can also read the description size. Do we have that? I think we don't have it, so leave that. And then we can start reading the actual GDT. Okay, for GDT we need the descriptor size. Oh, fuck it. Let's define that. ext4 DSC size, and the offset is 0xFE. Okay. If uh, number of groups less than 0 or mm, inodes per group less than 0 means if any of it is 0, that means I need to add a print statement saying something is fucking wrong, bro. Number of groups inodes is 0 why, and I'm just going to print two L values, and it's going to be number of groups and inodes per group. Okay, and both are digits, and I can add this. Okay, finally I can read the description size. It should be descriptor size, so it is ext4 descriptor size. Okay, and after that we go to GDT read. Maybe we can continue that next week. Let's just write to do. I have parsed all everything inside block 0. Now go to start reading block 1 and the GDT inside it. Okay, I think we also have everything to prepare the SB. Also create fill up the super block structs. We have almost all data needed for that struct. Okay. Nothing much. Now if let's run it once. Okay, it's working. We have block size of 4096, number of groups, current group count, and inode count, inode size, and it all makes sense because it's just 256, and these are the things that we actually talked about. So it looks like everything is parsable. So what is left to do is just parsing GDT, and then we should be able to start getting into the data blocks So, and also we can fill in all the structures and save it in a, global pointer so that we can use it anytime we want. Okay, I guess overall today we managed to write almost finish mount exec. We still have GDT passing, but it's fine. We have managed to finish a little bit, so it is okay. uh, Nothing much. Okay, thank you guys. I'll see you next week then. We'll continue that next week.